3.3, graphs of primary trig ratios. We recall that for a circle of radius 1, every point on it has coordinates p cos theta comma sine theta. So there is our unit circle, and its radius r equals 1. This is point P cos theta comma sine theta. This is our y, this is our x. And we also want to get familiar with how to identify the measures of angles using the radian measure. So this lets us first plot the points. So this point here is 1 comma 0, and this is 0 comma 1. This is negative 1 comma 0, and this point here is 0 comma negative 1. Those are the easy ones to say what cos theta and sine theta are for those angles of 0 radians, pi by 2 radians, pi radians, 3 pi by 2 radians, and 2 pi radians. You can easily tell what the sine and cosine are at those angles. What about the angles in between? So we have the first angle, which is from here to here, is our 30-degree angle. So this is our 30, and then this is our 45, and this is our 60. Or, in other words, this is our pi divided by 6, pi divided by 4, and 60 is pi divided by 3. So what would the sine cosine be for pi over 6? So cos of 30 is root 3 over 2. Sine 30 is half. 45, they're both 1 over root 2. 60, cos 60 is half. Sine 60 is root 3 over 2. 90, we already have it. Cos 90 is 0. Sine 90 is 1. So if you look at this blue over here, this is 30 pi over 6. And this angle here will also have the same answers that we have numerically for this point here, cos theta and sine theta. So it will be the same. It will be root 3 over 2 for cos and half for sine. But we also have to remember the cast rule. This is C-A-S-T, right? So we know that in this quadrant, only sine is positive. So this would be negative, because cos is negative in this quadrant. This angle here will be having the same sine and cosine numerically as what we have here for 60. And so that would be, sorry, for 45, or pi over 4. So it'll be 1 over root 2, 1 over root 2, but cos is negative here, so it's negative. And this one here will have the same as we have here. Cos is negative, so it'll be negative half and root 3 over 2. Okay? So when we go, when we think about this angle, if we go up, this is this angle here, I'm going to write it in blue. This angle here is pi over 6. This is 2 pi over 6. 2 pi over 6 or 60. And then you take, another 30 and you get to 3 pi over 6. And then this is another 30. This is 4 pi over 6. Another 30, this is 5 pi over 6. Another 30, this is 6 pi over 6. Another 30, this is 7 pi over 6. Another 30, this is 8 pi over 6. Another 30, this is 9 pi over 6. Another 30, and you get to 10 pi over 6. And then finally, this last one is 11 pi over 6. And then 12 pi over 6, which is the same as 2 pi. Okay? Continuing now with the answers here, the 7 pi over 6 will have the same answers as pi over 6, which is root 3 over 2 and half, but only tangent will be positive, so they both are going to be negative. This one here, which is the green line, it is the same as pi over 4. So it'll be 1 over root 2 and 1 over root 2, both sine and cosine negative, so they both will be negative. And this red one here is 8 pi over 6. It'll have the same numbers as 60, which is half and root 3 over 2. But both will be negative because sine and cosine are both negative. And finally, in the last quadrant, 10 pi over 6, it will be the same 1 half and root 3 over 2. Cos is going to be positive, but sine will be negative. These will be the same as pi over 4, 1 over root 2. 1 over root 2. But cos is positive, sine will be negative. And these will be the same as these here, root 3 over 2 and 1 half, but sine will be negative. So we can use this now to find the exact measures of angles. So if we had to find, say, sine of 11 pi over 6. So 11 pi over 6 is this angle here. It starts from the initial arm, goes all the way to here. Sine of 11 pi over 6 is negative 1 half, which is right here. Cos of 11 pi over 6 is 3 over 2. Okay. If we wanted to find sine of 5 pi over 6, that'll be 1 half. Cos of 5 pi over 6 will be negative root 3 over 2. And we need to kind of know our special triangles also, which we learned the last lesson. We're going to use this now to graph our primary trig ratios. We're going to investigate and graph y equals sine theta. I need you to have your graph paper ready and then fill first this table of values and then plot it. Okay, so we're going to use our measure in radians, 0. So if you look at this pi over 6, they're going up by 30 each time. Okay, that's 30, 60, 90, 120, 150, 180, and so on. So each time it's increasing by pi over 6. And so sine 0 is 0. I'm going to do this in red. Sine 30 is 1 half. Sine 60 is root 3 over 2. Sine 90 is 1. And then sine of 2 pi over 3 is root 3 over 2. So I'm just going to write the angles here just to kind of know. This is 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360 degrees. Okay, they're all in degrees. I wrote them up there so you can see what they actually mean in degrees. So sine of 150 will be the same as sine of 30. And it's in the second quadrant where sine is positive, so it will be 1 half. Sine of 180, well, think of the unit circle. The x coordinate is cos theta, cos of pi. The y coordinate is sine of pi, which will be 0. 7 pi over 6, it's 180 plus 30. So it's going to be the same as sine 30, but sine is negative in the third quadrant, so it's negative 1 half. 4 pi over 3 is going to have the same measure as 60, but it's negative because it's in the third quadrant. 3 pi over 2 is going to be it's going to be -1 because it's in the third quadrant where sign is negative, and it's going to be the same measure numerically as pi over 2. 5 pi over 3 is going to be similar to this, but it's in the fourth quadrant where sign is negative, so -√3 over 2. 11 pi over 6 will be the same as this, but negative because it's in the fourth quadrant, so it's -1/2. 2 pi, well, we're back to the unit circle, and its sine of 180 is 0. So these are the points we're going to plot. We have a graph here. This is 0, negative, this is +1, and this is -1. And we're going to go in increments of pi over 6. So this is pi over 6, pi over 3, pi over 2, 2 pi over 3, 3 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. So I'm going to change this a bit. Let me just change it goes from half. So this is 0. This is 0.5. This is 1. This is -0.5 and -1. So let's plot the points first. Sine 0 is 0. Sine pi over 6 is half. Sine pi over 3 is √3 over 2, which will be somewhere there. Sine pi is 1. 2 pi over 3 is again √3 over 2. 3 pi over 3 is again half. You can see the value I've got to here. Then back to pi, where sine pi is 0. And then the next one is -½. Then negative √3 over 2. Then -1. Then back to this one here. Then -0.5, which is this point here, and 2 pi is 0. You can take a pencil and draw a smooth curve to show one period of the sine function, where we wrote the angles in radians, and we went in increments of pi over 6 radians each time. Okay, you may want to know, once you've done the dotted line, join them to get this smooth curve like that. Okay, and that is y equals sine theta. One cycle. Okay, we're going to continue graphing. So another graph paper, we're going to do y equals cos theta. And, well, cos 0 is 0. Cos 30 is √3 over 2. Cos 60 is half. Cos 90 is, sorry, cos 0 is 1. cos 0 is 1. Then cos 90 is 0. And then it goes back to half, but negative in the second quadrant. Negative root 3 over 2 and negative 1. Now we are moving into the third quadrant again, where cosine is negative. So it's negative root 3 over 2, negative half, and back to 0. And the last quadrant where cosine is positive, so positive half, positive root 3 over 2, and then finally back to 1. Similar scale over here. This is 0.5 and 1, negative 0.5 and negative 1. And we're going to plot cosine 0 is 1. So we start right there. Cos of pi over 6. So let me just also write this. This is pi over 6. This is pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Cos of pi over 6 is root 3 over 2. Cos of 60 is half, it should be right here. Cos of 90 is 0. So we come all the way down here. And then the next one is going to be down here, negative 0.5. And then negative root 3 over 2. Next one, it's negative 1. Back to negative root 3 over 2. Back to negative 5, negative 0.5. And then back to 0 at 3 pi over 2. And then, oops, right here. And then 2 pi is 1. So now you take your pencil and draw a smooth curve passing through those points. Try and draw a smooth curve. And that's your y equals cos theta. Okay. Next, we're going to graph the third primary trig ratio, which is tan theta. So tan is 0, tan pi over 6 is 1 over root 3. Root 3, tan 90 is undefined. And then we go back to negative root 3. We are now in the second quadrant where tan is negative. Negative 1 over root 3, 0. And then you go back again to 1 over root 3. This is now the third quadrant where tan is positive, then root 3. And then again we hit undefined. Then we go back to root 3, but it's negative because now we're in the fourth quadrant. Negative 1 over root 3, and then finally back at 0. So there are places where it is undefined. So this is undefined. And then so here, undefined. So that means you cannot, those points won't be there. It might be there's a break in the graph at the undefined values. Let's label our graph. So this is our tan function. The values are different from what we had for sine and cosine. So we're going to use a different scale here. So let's say this is our 1. And then this will be our 1 over root 3 somewhere here. Similarly, on this side, this will be our negative 1 over root 3. Negative 1. So this will be, and this will be our root 3. Negative 1. And somewhere here will be our negative root 3. So we're going to start off at 0. Then you have to write our angles here, pi over 6, pi over 3, pi over 2, 0 pi over 2 pi over 3, 5 pi over 6, pi, 7 pi over 6, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11 pi over 6, and 2 pi. Tan of pi over 6 is 1 over root 3. That's this point here. And then tan of pi over 3 is root 3, which will be up here. And then tan of 90 is undefined. So we're going to have a vertical asymptote there because, you know, it's undefined and there's no point on that pi over 2. Then our 2 pi over 3 is negative root 3. So it will again start way back down here. Negative root 3. Then we go to negative 1 over root 3. Sorry. Negative 1 over root 3. Right here. We need one point here also, which is right here, 3. Then our value is 0 again at pi. So right here. And then at 7 pi over 3, it's 1 over root 3. So back here again. And then at 4 pi over 3, it is up here again, root 3. And then again, we are undefined. So this value, we're undefined. So we have an asymptote. Then we go back down to negative root 3, which is back here. Then negative 1 over root 3, which is back here. And then at 2 pi, it is 0. So like that. So if you take your pencil now and try to graph it, it looks like this. So it's a so your graph is approaching this vertical asymptote. Trying to draw a smooth curve, it actually looks something like this, where it's approaching the asymptotes on both sides. Here also it's approaching this asymptote, going like that. Okay, so that is how the tan function looks. This asymptote is x equals pi over 2. This is x equals 3 pi over 2. Those are the equations of those vertical lines. And that is the tan function. When we graph our primary trig ratios, we notice some characteristics. We have to look at the definition and also the values of each of those functions. What is the period, what is the amplitude, and what is the equation of axis? The period is the length of time it takes for one cycle. If f of x equals f of x plus p, then f of x is period p. Of a periodic function, an amplitude is a measure of the vertical rise and fall of the function. You have an equation where amplitude equals capital M minus lowercase m divided by 2. Equation of axis is the equation of the horizontal line that is halfway between the maximum value and the minimum value of a sinusoidal function. Equation-wise, it is equal to capital M plus lowercase m divided by 2, and this is only true for cos and sine functions. So let us summarize. For all of these graphs we did, it completes one cycle in 180 degrees. So the period for all of them is pi, and we're writing that in radian measure. They all have the same equation of axis, which is y equals 0, y equals 0, y equals 0. Amplitude is 1, and there is no amplitude, it's undefined for tan theta. Maximum value is 1. Tan theta has no maximum value. Minimum value is -1, and there is no minimum for tan of theta. The domain is x is a real number, x is a real number for both of them. And even for tan, but there are some values it cannot have. For example, x cannot be equal to plus or minus pi over 2, plus or minus 3 pi over 2, then plus or minus 5 pi over 2, and so on. Okay. Range is y is a real number, but there's restrictions. Y is between -1 and +1 and can take on those values, so equal to. Here also the range is y is a real number such that y is between -1 and +1 and includes those values. And the range is y is a real number for the tan function. That brings us to the end of this lesson.